do another example here. We're doing f of g of 1. So now we're doing g first. We're going to plug 1 into g. When we do that, we're going to get 2 minus the square root of 1 plus 3. So that's going to be 2 minus the square root of 4, which the square root of 4 is 2. So I'm going to get 0. 2 minus 2 is 0. But now I don't stop there. That 0 here is going to get plugged into f. So now I'm going to do f of 0. When I do that, I'm going to get 0 squared minus 4 times 0, which is 0. So that's how you do that one. Again, we started with 1, we plug it into g, and then whatever we get for output there, we plug it into f, and we simplify, and that's what we get for our composition. Okay, last one, we're doing g of 6, and as we saw earlier, it's okay if you compose with the same function. I'm just going to plug 6 into g, and whatever I get when I'm done, I'm going to plug it back in. So let's start by doing just g of 6. I'm going to get 2 minus the square root of 6 plus 3, which that will become square root of 9, which is 3. So I'm going to get 2 minus 3, which is negative 1. That's what g of 6 is, so now we're going to plug that into g again. So now we're going to do g of negative 1, which is going to give us 2 minus the square root of negative 1 plus 3, which that's going to be 2 minus the square root of 2. And that's going to be our composition of g of 6. We're going to end up getting that's 2 minus the square root of 2. Alright, so that's how you do it with just when you're given the equations and then you're given values. Okay? The next step is going to be plugging those into graphs where we're not given any equations, we're just given pictures. And at first this seems a little intimidating, but it's not too bad. Okay, just try it out with me. So here's f of x, it's this green function, and then g of x is this pink function. And what we're going to do is we're going to plug a value in, see what we get for the output. Then that output becomes an input for the other one, and we see what we get for that output. Once you start doing it, you get the hang of it pretty quick. So let's start with here. We're doing g of f of 1. What that means is we're going to plug 1 into f. So here's f. When I plug in 1, what do we get for the output? The output is 2. So then that 2 is what's going to get plugged into g. So now we come over to g. I say, okay, here's 2. When I plug that in, what do I get for my output? 3. So g of f of 1 is 3. All right, let's keep going. Now we're going to do f of g of 3. So I always rewrite it so I remember which one goes in first. We're going to g first. So when I go to g and I plug in 3, I get 0. So then I'm going to go to f at 0, and when I plug in 0, I get 4. So f of g of 3 is 4. Okay, keep on going. When we do g of f of 2, we're going to start by plugging 2 into f. And when we do, 2 gives me 3. So then I'm going to plug in 3 to g, and when I do, I get 0. Okay, what I would encourage you to do now is to push the pause button and then try to do these 3 on your own. Alright, you did it, right? Now push the pause button, push the pause button, and do these 3. Don't make me come through this computer screen and whatever phone you're looking at, okay? Alright, pause. Okay, now we're doing this. F of g of 0. Hopefully you already did this. I'm going to start with G and go to 0. I get 0. So then I come to F, and I plug in 0, and I get 4. Is that what you got? Hope so. F of 1, I'm just sticking with F here, I plug in 1, gives me 2. So then I go plug in 2, gives me 3. Then we do G of 1, I go to G, plug in 1, I get 3. That's getting plugged in again, plug in 3, and I get 0. I kind of like these ones, I think they're fun. Alright, we're getting there, we are so close. Let's just do, we got 2 more examples here. Of course, we've got a story problem here, and when you read it, you're probably like, that doesn't make sense, but it's not too bad. It's just a good example of a composition. So the surface area S of a sphere is a function of its radius r and is given by the formula blank. Suppose a sphere is being inflated so that the radius of the sphere is increasing according to the formula that, where t is measured in seconds and r is measured in inches. So basically, the surface area of this sphere, think of a balloon, but it's a sphere, not kind of a weird shape like a balloon, but just a sphere. It's being inflated, and this is the surface area depending on r. Well, our r is depending on time. So what this is asking us to do is to do a composition where now we can figure out the surface area based on the time. We don't really need to worry about the radius. It's kind of like the middleman, and we're cutting it out, okay? So all we're going to do on this is do S of, oh, I did the wrong one. I put F out of habit. So we're going to do S of R of T. What that means is we're going to take R and plug it into S. And that's going to give us the surface area in terms of time. So S of R of T. S is normally 4 pi r squared, but instead of r, we're plugging in 3t squared, and then we have to square that. And then we just simplify it, okay? So this will be 3t squared. 3 squared is 9, and t squared is t to the 4th. So this will be 36 t to the 4th times. So what that's saying is that if we want to know what will the surface area be according to the time, we just plug in how many seconds later, and that will tell us what the surface area is. So it's kind of like doing 2 things at once. It does this one, and then it does that one. So that's an example of how you can use this in more of a real-life setting. Okay, now, last thing we're going to do is working backwards. So now what they're giving you is saying, hey, this was a composition of 2 or more functions, and they can't be the identity function because that's cheating. It's got to be functions that you're actually doing something. And you're going to try to work backwards and say, hey, what would f be, what would g be, how could I maybe take 2 different functions and compose them in such a way that I would get that. There's more than one way you could do that. Let me show you an example here, okay? What if I'm going to pretend, so we're going to do f of g of x. So g of x is what we start off with, and it's getting plugged into f of x. So if I let g of x be 3x minus 1, and I let f of x be the absolute value of x, do you see how if I plug g of x into f of x, it gives me big f of x like that? It gives me this composition. That's one way you could do this. Another way you could do this is you could have said, I believe this one worked. Let me try this. If I let this be 3x, and this is the absolute value of x minus 1. I don't like the way that looks. Let's try this one. So then when I plug the 3x, do we get that? Yeah, there's more than one way you can do it, but you're trying to think, how could I break this down in such a way that I have 2 functions that when I compose it gives me this one, so you're thinking backwards. Pause and try to do this one. And hopefully you pause. Let me come back and just show you what I did on this one. We're going to do g of x is, I want one we start off with, I'm just gonna say it's x squared plus 1. And we're gonna plug it into f of x, which is just 2 over x. Okay, maybe there's another way you could do that, and as long as it works that when you plug it in, you get the same thing, then you're good. So that's some backwards thinking there. Alright, that wraps up 1.4, so now you can do the online homework and come back with questions for Wednesday. Alright, thanks guys.